Hi, boys and girls. Welcome back to another day of multiplying. I hope you're ready to do some extra special work with our numbers today as we consider carrying when we are multiplying numbers. To begin, what we want to do is start exploring on our own. So I want for you to take a piece of paper right now and multiply 36 times 2 using multiple strategies. And I want you to think back to the work we've done over the past couple of days and think about different ways that we could multiply 36 times 2. Pause this video, and then we'll come back and chat about a few of them. So one way to do this problem is with repeated addition. And to do repeated addition, well, it's 36 times 2, so I'm just going to add 36 plus 36, right? I add 36 2 times, and I get 2 in my ones place, and I carry, and I have 7 in my tens place. So my final answer is 72 with repeated addition. I can also take a look at the algorithm method, which we'll look at last. But we can also take a look at the number bond method. And I'm going to save this space down here at the bottom of my board. And looking at the number bond, I can think about 36 being broken down into 30 and 6. And I need to multiply those boxes by 2, right? So if 36 is being multiplied by 2, then 30 times 2, well, that's going to give me 60. And then 6 times 2 is going to give me 12. And we know that if I add these two pieces together, 60 plus 12, I get 72. Now take note that over here, the 6 is 6 ones, and I get 12 ones over here. So these 12 ones have to be regrouped. And since these 12 ones are being regrouped, I'm going to have 2 ones left over, and these 10 ones are going to become 1 extra 10. So it's like adding 10 over here. So the 60 really becomes a 7 tens, or 70. So we have 72. If I'm multiplying this out using the algorithm, 36 times 2 is 12 in my ones place. 3 times 2 is 6 tens, plus 1 is 7 tens. So all of my different strategies agree. Now I want to go back to the number that we looked at the other day when we first started working with multiplication. And this number is 342. And this is the exact same number, the exact same board that we worked with the other day. And I'm going to try to put the glare in the same spot. So I have 342. I want to show in my model what happens when I multiply this number times 3. So I'm going to show 342 3 separate times on my board. So here's 3 hundreds, 4 tens, 2 ones. Here's 3 hundreds, 4 tens, 2 ones. So let's take a look here and see what we have in each of our place values. So in my thousands, 10,000s, 100,000s, I don't have anything going on up there. In my ones, I have 2, 4, 6 ones. In my tens, I have 2, 4, 6, 8, 10, 12 tens. And I have 9 hundreds. And this number we know right here can't exist because we can't have 2 digits in a place value. So I need to take 10 of these items and regroup and fix. So I have 10 tens become 100. So if that's taken place, now I have 2 tens left over, and now I have 10 hundreds. Well, wait a second. We know that if I have 10 in a place value, I need to regroup. So I now need to take my 10 hundredths and make these become 1,000. So what I just showed here in this crazy model with my marker chips was 342 times 3. And if I run this number through with my algorithm, I have 2 ones times 3 is 6 ones. I have 4 tens times 3 is 12 tens, and I carry. I have 3 hundredths times 3 is 9 hundredths plus 100 is 10 hundredths, or 1,000. So my final answer is 1,026 if I'm following my algorithm or if I'm using my chips and showing all the regrouping steps that are actually happening in my number. Today, we're going to see a lot more of these regrouping steps in the middle of our number. Let's do a few examples together. So in this very first example, I have 415 times 3. And I've already decided that I want to model doing this problem by using the number bond. We can do repeated addition, sure, and we can do 415 plus 415 plus 415. I like 3 add-ins and having all of those numbers there. However, I'm modeling this problem using a number bond. And remember, I'm going to first write down the value of each digit. So this 4 is in the hundreds place. It's worth 400. And then my 1 in my tens place has a value of 10. And then my 5 in my ones place has a value of 5 ones. And remember that I'm going to multiply each of those by 3. And I'm going to get my answer, or my answers to each of these smaller questions, and then I'm going to have to combine those place values. So I have 5 times 3, well, that's 15 ones. And there we go. I'm going to hide the 5. So I have 15 ones. I have 10 times 3 is 30 over here. And then I have 400 times 3 is 4 times 3 is 12 with hundreds at the end. So that's 1,200. And now I have to add all of these pieces together. So I have 1,200 plus 30 plus 15. So we had a lot of carrying going on here. Adding these up, I have 5 in my ones place. I have 4 in my tens place. I have 2 in my hundreds place. I have 1 in my thousands place. So 415 times 3 is 1,245. Now this work here actually ends up showing up in our algorithm. If we wanted to quickly explore this work, we could see when we multiply in our algorithm 415 times 3, I'm going to get 15 ones, right? Just like I did over here. So 5 times 3 ones gives me 15 ones. I write down my 5 in my ones place, and I'm carrying that 110 over into my tens place. 3 times 110 is 3 tens, plus the 110 that I carried before. Well, that's 4 tens. So I had my 30 from 10 times 3, and then I had the extra 10 from the ones that I carried over. So far, my answer matches. Now I have 3 times 4 hundreds is 12 hundreds, or 1,245. Let's take a look at these final 2 examples. And what I want for you to do is pause this video very quickly, work on these 2 problems, and then come back and check your work with me. when you're done working on these. So take a look at 96 times 4, and I'm going to do this with the algorithm method in mind. So I'm going to solve 6 ones times 4. 6 ones times 4 is 24 ones, but I'm not going to write 24 because I'm going to carry that 2 up here. I can also do 4 times 9 tens, which is 36 tens, plus 2 more tens is 38 tens. And I have 384 as my final answer. Now, we can also do the number bond method up here without doing all the number bond work. And I'm going to model that on 463 times 5. And what I'm going to do is write down the place value of each of these digits, and then we'll add everything together at the very end. So 5 times 3 is 15 ones. So I'm going to write 15 down on the bottom. 5 times 6 tens is 30 tens. Well, 30 tens does not look like this. That's 30 ones that I've just written on this board. To have 30 tens, I need to move over a place value. So 30 tens looks like this, 300. Then I have 4 hundreds times 5. That's 20 hundreds, or 2,000. This looks like the number bond method kind of in disguise now, doesn't it? And if I add these up, I have 5 ones, 1 10, 3 hundreds, 2 thousands. So my final answer is 2,315. And I'll get rid of my work over here, and I will show you that 463 times 5. If you did it with the algorithm, you got 15 ones, you have 30, 31 tens, and you carry 3 tens over. And then we have 20 hundreds plus 3 extra hundreds is 23 hundreds, or 2,315. So today, we saw that we could also use the number bond method to break down our multiplication problems into individual steps, but we have to be really, really careful about our place value. You can continue to use the traditional method, but be very careful when you're using this algorithm. Sometimes you're carrying a 2 or a 3 or even a 4 or greater if the facts are that big. For example, if I had to multiply 9 times 9 tens, well, that's 81. So I'm writing down a 1 and carrying an 8. So imagine what those numbers that I could carry could end up looking like. And remember to always add in what you've carried. Today, what you're going to do in your math journal is this particular math journal assignment. You are going to be multiplying 284 times 4. And I want you to show your work using 2 different methods. So those methods, again, we can think about those methods as breaking down our work, just like we did on this problem here with our place value, kind of under the traditional algorithm. We can do the number bond drawing, we can do repeated addition, or we can do the regular traditional algorithm like we showed over here in this work as well. So you're going to do 2 different methods for 284 times 4. Then I want you to tell us, which method do you prefer to use and why do you prefer to use it? When you're finished with this assignment, you're going to check on Edge Elastic for a post on multiplying numbers today. There might be carrying in some of these examples and there might not be. So check your work very carefully and then submit your answers once you're finished. Please listen to your teachers for anything they may want you to do after you finish Edge Elastic. And we'll see you back here tomorrow for even more work with multiplying numbers.